Welcome to Speaker Series. This is usually a monthly event that we offer for free for members and the general public. And we're trying very hard to offer a really nice variety of speakers from artists, authors, researchers, biologists. And tonight we have a special guest, Sahas Barve, who is, well, I'll tell you a little bit more about him in a moment, but first I would like to just remind you that the event you're attending tonight is free. If you're not already a member of Audubon, we would love to have you a part of our group. Um, your membership fees go to support our efforts to teach about the environment, teach about birds. We have classrooms, classroom programs for elementary school students. We've got environmental advocacy, and of course, we have birding. The birding right now, as far as field trips and such, is kind of on hold. And what we've been doing during the pandemic is using this time, this downtime, to improve our website and a huge number of self-guided trips, our virtual field guides, uh, uh, and producing videos on educational topics, bird topics and environment. So we have a YouTube channel. We've got a fabulous website with more and more content every week. And I'm hoping that if you haven't already been there, you take a look at it soon and become a member if you aren't already. But back to Sahas. So Vivek Hansadeh introduced us a little while ago. Vivek is on the board, as is Barry, who's on the top shelf here right now. Um, Sahas has done his graduate work on the acorn woodpecker. And I called him because I love acorn woodpeckers myself. And I said, I'd love to have you do a speaker series for us because I want to get researchers in. I want to get actual hardcore field research in here. And I love it if you could tell a story about woodpeckers. And I think Sahas is going to do just that. He's been studying about behavior and the colonial lifestyle of acorn woodpeckers. And of course, where he lives in Washington, D.C., there are no acorn woodpeckers. So actually, he's a little bit jealous of us right now because we see them pretty much every day. And so try not to make him feel bad about that. He grew up in Mumbai, where he went to undergraduate and then moved to the United States to get his PhD at the Cornell Lab of Ornithology. And then he followed that up by doing full-time research at the Smithsonian in Washington, D.C. So he was actually there today and has been for quite a while in the middle of everything there. And I'm sure the energy was pretty high today. So I'm so glad you took the time out of the day and the excitement to join us tonight. And like to welcome him in a moment and remind you all that when he's done speaking, we'll take a few questions afterward. And if you look on the bottom row of your screen, you'll see the chat area. There are already some messages there. So if you'd like to enter your question in the chat, Barry will sort of monitor them. And then we will, so that Sahas won't have to look at the chat while he's speaking, but Barry will monitor that and dig out the best and most interesting questions that we've got time for. And after he's done, he'll go ahead and field some of those questions. So without any further ado, Sahas, I would like to welcome you to Speaker Series. Thank you so much for taking time to be with us tonight. I can't wait to hear what you have to say, and I'm going to hand over control to you. Let me see, right now. Let me see, make host. So you should have the host on right now. And I'll remind everybody that tonight's speaker series is being recorded and it'll be posted on our website. We'll take out all the names and stuff at the beginning, so you needn't feel shy about that. It'll just be the talk, which will be posted on our YouTube channel. And with that, Sahas, take it away.
Great. Thank you so much, Matthew. And thank you to all of you for joining and attending. Let me start presentation. I hope you can see that. Barry, give me a thumbs up if you can see it.
Absolutely.
Great. Awesome. All right. So again, thank you so much for joining. And my name is Sahas Barve, and I'm a Peter Buck postdoctoral fellow at the Smithsonian National Museum of Natural History. And I've been studying acorn woodpeckers for the last 4 years. And this question, do acorn woodpeckers make granaries or do granaries make acorn woodpeckers, is obviously something that I'm not going to answer today because it's mostly a chicken and egg question. But I hope I can tell you a few really, really interesting things about the social lives of acorn woodpeckers. And before we get to acorn woodpeckers, I kind of want to talk to you about family living. So humans live in families, and they might be multi-generational families or at least two generational families. And but I wanted to ask you if you have ever thought of why we live in families. Uh, there is a huge diversity of animal sort of lifestyles, right? So, for example, tigers and mountain lions live alone. They are solitary animals. They don't need anyone else. While there are gelada baboons and chimpanzees that live in big, big groups. So, why do some animals live in families and why do others live in families? And why do humans live in families? What do we have common with animals uh, that are social? And we are going to try and answer some of those questions with regards to acorn woodpeckers today. So a quick bio of acorn woodpeckers. I'm sure you've seen this bird in your backyard. It's found throughout Western North America and down all the way to the country of Colombia in South America. And it's always associated with oak trees. And acorn woodpeckers, I'm sure you know, are famous for building these large acorn granaries. And these granaries are sort of the hallmark of their territories, and they protect them viciously against crows and jays and squirrels, and they will play a big role in today's story. But I want to take you back to the year 1925, and Frank Leach, a scientist back then, I think at the University of Berkeley, wrote this paragraph about the acorn woodpecker. And he said one of the most puzzling features of the nest building was the fact that more than a pair of woodpeckers seemed to be interested in the proceedings. And back then, this was a really, really interesting observation. Uh, Most animals till then were supposed to be pair living, where a male and a female got together, at least in the breeding season, to raise a few offspring that they fledged or brought to adulthood, and the adults just dispersed. But here was a bird where obviously more than two adults were taking care of the offspring in the nest. And that was a really interesting observation that scientists didn't have a good answer for. Then that simple observation led to a guy called McRoberts, who studied them at Hastings Natural History Reservation in Carmel Valley, California. And he found that these extra birds that were feeding young were in fact offspring from previous years. So these birds were not strangers, but were basically the older siblings of the offspring in the nest at that time. But then the question is, why raise offspring that are not your own? What is the benefit of raising offspring that are not your own? And this was a burning question in behavioral ecology back in the 50s and 60s, because it was increasingly being discovered that there were a lot of animals, for example, bush tits, scrub jays, a lot of animals uh, in North America and the world over that had what scientists called helpers. These helpers were non-breeding adults in the group that were helping raise offspring in the nest. But what is the benefit to these helpers for raising non-descendant kin? The sort of the proximate uh, advantage is that, well, these offspring from previous years are hanging out in their parents' territory because they can't find an independent breeding opportunity, a territory of their own where they can find a mate and raise their own offspring. So they hang back and help out with the family. And as I alluded to in the previous slide, this form of breeding is called cooperative breeding. And this form of breeding where more than two parents take care of the offspring is not at all common. It's actually not even restricted to birds. So about 9% of all birds in the world show some form of cooperative breeding. And here cooperative breeding is 3 or more adults taking care of the nest. But it has evolved multiple times independently. So within birds, ostriches, bush tits, jays, woodpeckers, cuckoos, babblers, a bunch of different birds belonging to different families have shown independent evolution of cooperative breeding. And cooperative breeding is not only found in birds, but is also found in mammals, also found in reptiles, and even some insects. So there is something really, really important about family living, and it gives these animals some evolutionary advantage. Because let's go back to the grand old daddy uh, of, of evolution. Charles Darwin basically said that, and this is a sort of really, really bad condensation of his theory of evolution by natural selection, but he said that it was the survival of the fittest, and the fit are the ones that leave behind the most copies of their DNA. And these animals are the most successful in the gene pool. So for the longest time, the only way to leave, or at least people thought that the only way to leave behind many copies of your DNA was having more babies or more offspring, which gave you higher fitness. Okay, and this is evolutionary fitness, not physical fitness. But the question is, does it have to be offspring? And I sort of want to get out of this presenter mode and ask you this question: who else shares your DNA with you? So can you guys chat, put answers to that question in the chat? Who else shares your DNA with you?
It's easy. Our kids.
Yes, that's awesome. Danny saying my sister, Barry saying parents, Priya saying siblings. Great, siblings, family and relatives, cousins. Those are all absolutely correct. So let me share my screen again, please. So great. Um, all of those answers are right. We know that brothers and sisters are your siblings, cousins, nieces, nephews, grandchildren, uncles, second uncles. Everyone shares some part of their DNA with you. Now, the next question is, I kind of give you the answer, but how much DNA do you share with these people? So how much DNA do you share with your son or daughter or your offspring? How much do you share with your sibling? And how much do you share with, say, your nephew or niece? So can we get some answers to that potentially?
Percentage.
So let's see. Let's answer this question. How much do you share with your offspring? Yeah, with your son or daughter. Carol says 50%. Vivek says 50%. Danny says half, 50%. Okay. 50% or more. Okay, how about sibling? How much do you think you share with your sibling? Okay. Less than kids. Okay. 25%. Anyone else? Siblings. And then how about your brothers or sisters' offspring? Your nephew or niece? How much DNA, how much of your DNA do you share with them, with your niece or nephew? 1/8. Okay, less than any of these others. Janet says. I would think 25% with niece or nephew, Carol. Okay, great. These are all excellent answers. So let me give you some answers. And this is obviously an average, but and based on probability and genetic averages. But you basically share about 50% of your DNA with your kid, but you also share 50% of your DNA with your sibling, and you share 25% of your DNA with your nephew or niece. And so, if your lifetime goal is to leave behind as many copies of your DNA in the gene pool, then you need to have 2 offspring to replace yourself in the gene pool, or make sure that you have 2 siblings that go on to have children of their own. And then you're replacing yourself in the gene pool. If you have 2 offspring and 2 siblings, then you've already been replaced twice in the gene pool. And that goes on to say, obviously, that if you have a nephew or niece, then 4 of those nephew or nieces will replace you in the gene pool. So if you have 8 cousins, for example, you're replaced in the gene pool. If you have 16 cousins, you've been replaced twice in the gene pool. And so JBS Haldane, a famous statistician and geneticist, said that I will lay down my lives for 2 siblings or 8 cousins. So here's the catch. If leaving behind as many copies of your DNA in the gene pool is what gives you the most fitness, then it doesn't have to be kids of your own. It could be your siblings or your brothers or sisters' kids as well. And so was born this theory of what is called kin selection, where it basically says that organisms that helped raise siblings or close relatives left behind more copies of their DNA than organisms that don't. And then this leads to more social birds in the population and a higher prevalence of cooperative or social behavior in that population, potentially leading to the whole species being social eventually. But let's come back to the question of how does this cooperation or cooperative behavior contrast with the drive to maximize one's own individual fitness? Why should I help raise 4 of my brother's kids when I can have only 2? Right? That's a very basic question. And so people have been trying to apply kin selection and other theories to humans, but let's not get into that. Let's think about kin selection from the point of view of these amazing neighbors of yours, acorn woodpeckers. All the research that I'm going to talk to you about today took place at the Hastings Natural History Reservation in Carmel Valley, California. It's a UC Berkeley nature reserve site, and it's actually one of the oldest biological research stations in the country. It's also one of the longest running. So the acorn woodpecker project that I'm going to tell you about is one of the longest running continuous studies of any bird in the world. And it's taking place only 2 hours south of you guys. So if you have the time, you guys should go visit Hastings. And it's a wonderful place. And there are woodpecker researchers that you can meet. And it's a great place to hike and see some cool birds. And if you haven't seen the Lawrence's goldfinch, I haven't seen a place where they're more common than Hastings. So I generally put that in for when I talk at conferences or speakers where they don't know where Carmel Valley is. But all the research that I'm going to talk to you about today was led by this guy, Walter Koenig. He worked for the University of California, Berkeley, but obviously he can't do 50 years of research alone. He has been helped by a bunch of different people, and over 200 people have worked on this project since 1968. So the data that I'm going to share with you is here only because of the hard work and sweat of a lot of people. So, okay, let's go back. We initially talked about there being breeders and helpers in these acorn woodpeckers. There are these a male and a female who are breeders. Then these offspring from previous years that hang back and help raise their siblings. They're called helpers. But as Walt started studying woodpecker groups at Hastings, he realized that the social system of these birds was much more complex. So within those groups, there were some groups that had a simple male-female pair and no helpers. Okay, so just two birds, one male, one female, raising chicks. There were polyandrous pairs, which means that there were more males than females in the group. And this is typically a pair of males with one breeding female, and the two males cooperatively breed with the one female. There are polygynous or polygynous groups of acorn woodpeckers, so multiple females breed with one male. And there are polygynandrous groups of acorn woodpeckers where there are multiple males and multiple females all living together, all raising a communal nest of offspring every year. And all these combinations may or may not have a non-breeding helper or helpers of both male or female sex. Okay, so within the 50 to 55 groups that we study, we have this much crazy diversity of social systems. So imagine if you're living in a village of 50 households and you have that many different social systems in the same area. The other crazy thing about acorn woodpeckers, obviously, is their granaries. And I'm sure a lot of you have seen these granaries maybe in your backyard or on your hikes. And acorn woodpeckers store thousands and thousands of acorns every year in the fall. And these granaries can be a few hundred holes to tens of thousands of holes. And we have some granaries at Hastings, which we think have over 50,000 holes. These granaries are built over generations of woodpeckers, and they are essential for acorn woodpecker survival. Acorn woodpecker society, in fact, is basically, they love living in oak savanna and they live by their granaries. So acorn woodpecker territories are defined by their granaries, and the groups all hang out near the granaries and defend them. So the initial hypothesis of why these birds live in groups and why there are non-breeding helpers that are raising their siblings is that territories with granaries are limited in the landscape. And so you can't start breeding as an adult unless you have a granary. And so you have to bide your time hanging out with your family, not moving out until you can find a territory where you have a granary, and then you can start breeding as the breeder in the group. Okay. So then from an acorn woodpecker point of view, a really important question is, how do you acquire a granary? How do you get a breeding position in a territory with a granary? And so the question, how do you acquire a granary, is also the same as how do you get a breeding territory. And there are two ways in which an acorn woodpecker can get a granary. So let's talk about those really quickly. So consider a family. This is a very simple example. Let's consider a family where there is a male and a female breeder. So here's the parents, and they have three non-breeding helpers in their groups, two females and one male. Okay. Now let's say they are living on a territory with a big granary, and they all store acorns every year and are living peaceably. Now let's say that the male dies. Okay, so the father of these non-breeding helpers is dead, and there is no breeding male in the group. So what's going to happen is that multiple males from different territories are going to fight to win the territory, to win this granary, and access to these females. So these events are called power struggles, where multiple coalitions of males, so each coalition has between 1 to 4 adults. So but generally they have 2 to 3 males. So 2 to 3 males will come together and fight one another until one coalition beats all other coalitions to then win access to this granary and the female breeders. So, oops. So when that happens, let's consider that the males have, these 3 males have won the power struggle. These 2 females now have unrelated males moving in. So let's see, these 3 males won the power struggle, and these unrelated males are moving into the territory where there are 3 females potentially. So these 2 females become breeders because they inherit the territory. And that's the 2 ways of winning of acquiring a territory in acorn woodpecker world. You either acquire the territory by fighting with other birds, or you inherit the territory when the opposite sex parent dies. I'll break this down more for you in a second. So these adults move in, these helper females become breeders now. They become co-breeders, and the new males kick out the helper male and become breeders. But I just described a really, really socially complex phenomenon to you, that multiple coalitions of birds somehow find out that there is a breeding vacancy available in the habitat. They fly there, they fight against each other, and they somehow decide which coalition has won. How does that work? How do birds know that there's a power struggle or a territory vacancy available? And how do they come in from miles? So we know this. We know for a fact that birds are coming in from miles away because we have color banded birds that are spread out over 1,000 hectares in this habitat. And so we can read the color bands of birds coming in, and we know that these birds are flying in from miles within minutes. So how do birds find out that there's a power struggle happening miles away within minutes? To answer that question, we set up a really nifty system. So let's revise that. Woodpecker Society is made up of territories spread out over the oak savanna, and whenever all the breeders of a particular sex die in the group, multiple coalitions of birds come in and they fight. These fights involve posturing, actual fighting between birds, and a lot of watching. And I'll come to that watching part later. But multiple birds will come and fight another. These fights are really, really serious. So there's birds that are gouging each other's eyes out. We see birds that have broken wings, birds that grapple with each other, fall to the ground. So they are really fighting. They're not kidding around when a big granary with hundreds of holes is at stake. The problem with understanding these really complex battles is that they are really difficult to observe. It's 40 or 50 birds fighting at the same time, constantly flying around, and reading their color bands is almost impossible for a human observer because it's so chaotic, and you just keep seeing the same birds over and over and over again. You often can't see all the birds because there are birds fighting on all sides of the same tree. And keeping track of how long each bird is actually participating in these fights is almost impossible. So we used a brand new, very cutting edge radio tag to help us answer this question. So these radio tags are ultra light, so they'll weigh less than a gram, and they are solar powered. So if you see right here, this black square is actually a tiny solar panel on the tag. They sit on the back of the woodpecker like a rock climbing harness. And these tags are picked up by solar powered receivers. So every time a woodpecker flies past one of these antennas, and we put these receivers and antennas close to the granary, it gets picked up, and we get data. So with this technology, we can track each radio tagged woodpecker all the time and continuously. So we can track, well, I think the most we've had is 121 woodpeckers simultaneously radio tagged, and we were tracking all of them continuously and simultaneously. The only downside to this technology is that it's solar powered, but thankfully for us, Carmel Valley, California has a lot of sun. And I think especially that part of Central Coastal California has, if I'm not wrong, some crazy 330 days of sun or something. The technology works in cloudy weather as well, but the sun definitely helps. So we studied 3 of these power struggles, and we had 36 radio tagged woodpeckers that we had data for that actually attended these power struggles, out of which 13 were birds that were actually fighting to win the power struggle. So these were birds, and in fact, the 3 power struggles that we studied were female power struggles. So instances when all the female breeders in the group had died, and multiple female coalitions were fighting each other to win breeding rights at that territory. So there were 13 female helpers that we were tracking, and 23 what we call spectators. And let me tell you what the spectators do. These birds are birds that were detected really close to the power struggle site. So they were present at the power struggle site, but we know these birds have breeding territories of their own. So there is no way they are interested in these power struggles for them to move in as the breeders. And the other thing is, many of these spectators are also male, and these fights were for female breeding vacancies. So why were these males or these females that already had breeding vacancies, why were they being detected at these power struggle sites? So what we found out was that birds spend a lot of time at these power struggles. And so we found all sex and status categories. So we have 2 males and females and 2 statuses, helpers and breeders. And we found birds from all sex and status categories visiting the power struggle sites. And some birds were visiting from up to 3 kilometers away, so up to 2 miles away. And some birds were present for over 10 hours every day. Now, the warriors in these groups, the warriors is what we call the females that were actually vying for these breeding vacancies. They obviously spent significantly more time because they were fighting at the power struggle sites, but the spectators spent quite a lot of time as well. Some of these females that we were tracking spent over 10 hours every day for multiple days, fighting continuously from sunrise to sundown to win these power struggles, and then still lost. They did not end up winning the power struggle. While these spectators, which had in many ways nothing to gain from these power struggles, still ended up spending about an hour every day, potentially just watching the fight. In fact, the spectators that we detected came from further away than where the warriors came from. So the spectators on average came from about 2 kilometers away or 1.5 miles away, while the warriors often came from within a kilometer from where the power struggle was actually happening. So the spectators were leaving their own territory unattended to come watch this big fight happening. And they came just as frequently. So these power struggles, the big ones especially, last for many days, and they have birds fighting from dawn to dusk for several days. And so we had not only some birds that come to fight for up to 5 days straight, but also some birds that come to watch every day as well. So what did we learn from this? So for birds that take the fight strategy to inherit or win to win a breeding territory, spend a lot of times, over 40 hours, fighting on an unsuccessful attempt at winning a territory, and that there are spectators in the population that just go watch fights. And we really don't have a lot of understanding of why they spend so much time and effort into watching. But we do know that acorn woodpeckers know each other, know the birds in their population individually, and it seems like these birds are going to gather social information. So they go in to see who the big coalitions are, who are the big strong coalitions, and maybe they suss out competition for their own offspring in the future. We don't know, or they may just like to watch a good fight, like some people do. So um, it was a really cool finding, and a good way to understand what is driving the sort of the crazy drive these acorn woodpeckers have to win their own territory and fight for their own territory. Um, at this point, maybe if you guys, maybe I can answer some questions. Is that okay with you, Matthew? We can take about 5 minutes to answer some questions and get back to the next part of
Sure,
the
that'd
talk,
be
just to
fine.
break things up.
I'm just typing up a question myself. So if Barry, you have a couple of questions that you've identified, go ahead. And
Yeah. Okay. Yeah, I've got quite a few. Ed Ching asked one directly of me, so I'll pass it along, which is, do the granary holes that the acorn woodpeckers make affect the trees?
That's a good question, Ed. So most of the granary holes are made in dead parts of the tree, and the most commonly used tree, which is valley oaks or Quercus lobata, has really thick bark. So the holes never actually get into the wood. So they actually, unless, I mean, I'm sure if you're a parking garage or a shed, they'll probably make a granary in that, and that'll damage the shed. But they rarely damage trees.
Huh, interesting. John Harshman wants to know, who's your PI at Smithsonian? He asks because he did a postdoc with Mike Bryan.
Oh, cool.
Mike Braun,
Braun,
sorry, excuse me.
Yeah, so I work with Carla Dove in the Federal Lab at the Smithsonian. Cool. And that's great, John. I'll pass on your hi to Mike.
Cool. Emma Shelton says, I love the graphics and this whole talk. And she wants to know, and I have the same question, do the woodpeckers have a preferred species of oak tree?
Mm-hmm. That's a great question. I don't think they do, but if you want acorn woodpeckers to live in your neighborhood all year round and have a good population, they generally like to have 2 to 3 different kinds of oaks. So acorn woodpeckers rely on acorns, as I'm sure you know, but each oak species has a big crop of oaks in sort of at different years. So if you have, say, valley oaks, blue oaks, and coast live oaks, then one of those 3 species will have a big acorn crop in any given year. And they have these masting events where all the trees in the same area generally have a big crop of acorns. And so acorn woodpeckers love to live in places where there are 3 or more species of oaks, because then every year they have at least one species they can rely on for a big crop. And so the answer to your question is they like more acorns or more species of oaks than any one oak. But at the same time, if you have valley oaks in the at least in our field site, they tend to love making nests and granaries in valley oaks, and they like to make granaries in sycamores as well.
So I have a question, if it's okay.
Sure. Go for it.
One question I have, I think you're going to talk about later, because we talked about it on the phone a week or two ago about how they recognize each other. So I'll let you talk about that later. But I was curious also, because we had on a previous talk, we had Steve Shunk show up and speak about woodpeckers, and he talked about many species and their importance in the environment and the ecosystem. Right. One thing that really struck me is he said that a primary food source for acorn woodpeckers is insects, and that they do an awful lot, like all the Melanurpes do, a lot of aerial insect capture, grasshoppers, beetles, things of that sort.
Right.
So I was just wondering if you could explain why the acorns are so important
Mhm.
to acorn woodpeckers if insects are such an important part of their diet.
That's a great question, Matthew. And yes, acorn woodpeckers are insectivorous birds. In fact, the Latin name of acorn woodpeckers is Melanoropes formivorus, which means that they're ant eaters. But as Matthew rightly pointed out, acorn woodpeckers are actually flycatchers. They love to sit at the top of trees and go sally insects, and they love crane flies and flying beetles and grasshoppers and such. But as I'm sure you know, because you guys live there, California winters are often wet and cold and dank, and there are very few flying insects on such days. And that's when they rely on the acorns. And so acorn woodpecker overwinter survival is tightly linked to the size of their granary. And the more acorns they have stored away, the more cold and rainy days they can endure. And so that is why those acorns are really, really important. So they are an external, as we like to call it, they're an external fat reserve for these acorn woodpeckers. They can't put on fat in the winter like bears do, but they can store it in a larder that they can go to any time and have an acorn if they can't find insects.
That makes a lot of sense. Thanks for explaining that. And it reminds me that another Melanoropes that you see much more often than we do, red-headed woodpecker, it's more migratory.
Right,
I believe.
exactly.
So it would have a more sustained food source of insects.
Yeah.
And
so
yeah.
Yeah, and so even the acorn woodpecker in Arizona, the population in Arizona, do not build granaries, and they are a lot more migratory also. So they move around a lot in the winters because they don't have a convenient granary to go have a snack when they're hungry.
Well, thank you.
Acorn woodpeckers also, by the way, feed their chicks acorns, and so acorns are important for them for multiple reasons. So let's go back, and I want to answer Lisa's question in the end. So Barry, if you can remind me to talk about that. But
I'll pick up from there on when we get back to questions.
Great. Okay, so let me go back to my talk. So I have told you that there are two ways to be an acorn woodpecker and be a breeder, become a breeder, have your own territory and your granary in the acorn woodpecker world. One is to inherit the territory, or the other is to fight for it. And in the first part of the talk, we saw how these males may fight with other coalitions and beat a bunch of different coalitions, all the big coalitions in the neighborhood, to win access to these three females that are now co-breeding or joint nesting to form a communal nest. Now, imagine there are 6 individuals in that group, 3 males and 3 females, and those 6 individuals are trying to compete with one another to maximize each individual's direct fitness. Okay, so in this case, what's going to happen is that those 3 females, they might be a mother and 2 siblings, which means that they're equally related to each other, right? Because mothers and daughters are 0.5, siblings are 0.5. And so they're all equally related to each other. Let's consider that the 3 males that just joined are all brothers. So they're all equally related to each other as well. But we know that you get higher fitness by raising 2 of your offspring than 2 of your nephews or nieces. So when these birds are having a communal nest with their close kin, how do these birds make sure that they maximize their own individual fitness? And this leads to the question or the problem that there is a lot of intra and intersexual competition. So intrasexual between the same sexes. So males and females are competing with all the 3 males, and all the 3 females are competing within themselves to make sure that one of them, each one trying to maximize their fitness. while there is competition between the males and females as well. So the males are trying to maximize the number of chicks they can have, and the females are trying to maximize the number of chicks they can have as well. So how do they make it work once they have breeding territory? Now, let me tell you that joint nesting with multiple females having a single nest is a very, very rare behavior. It's shown by acorn woodpeckers, but acorn woodpeckers are only one of 8 species in the world that actually show this behavior. So there's a couple of species of mouse birds in Africa that show this. There is a couple of anis in Central and South America. So if you've been to Texas or Florida, or I don't know if there have ever anis been seen in California, but anis have joint nesting by females. There's acorn woodpeckers as well. Magpie jays in Central and South America have a species, the white-throated magpie jay, which has multiple females breeding together. And then one species in Asia called the Taiwan Yuhina, which has multiple females joint nesting to have a communal nest. The reason why this, or maybe one of the reasons why this behavior is so rare, is because of these intra and intersexual competition. Now, when you think about from the female's perspective, polyandry is the best case scenario for females, right? So you have one female, she wants to mate with as many males as possible that together rear her chicks. So one female mates with 2 males, and she maximizes the number of eggs she can produce in that season. The males work really hard and take care of all her chicks that year. So polyandry is the best case scenario for females. So then that gives us the prediction that joint nesting coalitions of birds will have, when there are joint nesting coalitions of females, they will always have more males than females. So they will always maintain this polyandrous sex ratio within the group. So even if there are 2 joint nesting females, there'll be 3 or more males in the group. Exact opposite of this is true for males. For males, polygyny is the best case scenario. So consider that, like, if there's a male in the group, if he has 2 or more females, then he can simultaneously have twice or thrice the number of babies that he would have with one female breeder as his partner. So for the male, having as many females as in their group is the best idea, and maintaining a polygynous or polygynous sex ratio in the group is the most advantageous. But a case where female coalitions might be also beneficial for males is that it can reduce what is called reproductive skew. So in general, as I'm sure you know, there's a female bird becomes receptive. There is generally one male that guards her, what is called mate guarding in her receptive period, and the male follows her and makes sure that no other male mates with that female while she's receptive. Now consider a scenario where there are 2 males and 1 female. One dominant male amongst those 2 can mate guard 1 female the whole time and make sure that he fathers most of the young in the next brood. Such a scenario will have a high reproductive skew, where one male is the father of most of the offspring in the nest. But when there are multiple females in the group, one dominant male can't chase and can't mate guard all the females simultaneously. And that's why one advantage of having multiple females in your group is that it reduces the reproductive skew amongst males. It makes the mating and the paternity more equitable. So what drives joint nesting in acorn woodpeckers? One thing that I would like to tell you is that this data comes from about 50 years of continuous research. And we only have sample sizes and we have enough instances to study this rare behavior because we have been studying these birds for the last 50 years. Because even in our uh, long-term population, 78% of the groups have only one breeder female. Only about 22% of the groups have more than one and up to four co-breeding joint nesting females in the group. Okay. So how do they do it? The other problem for the females is that, let's say a uh, female A, or let's say Anna here. Let's consider a two female example. Anna here lays an egg. If she lays 3 or 4 eggs before Elsa does, then Anna's chicks are going to hatch out earlier than Elsa's, and they are going to have a tremendous advantage, a growth advantage over Elsa's chicks. And so Elsa is going to be left behind raising her nephews or nieces rather than raising her own kids. Because if you're in the same nest, generally, if you have really big nest mates, those big nest mates get fed more. The weaker, smaller chicks often die. So then how can Elsa make sure that she also has an equal say, or that her chicks also have a fighting chance in the joint nest? And this is how they do it. So let's say Anna and Elsa are two joint nesting females. They live in the same group. They are sharing a nest. Anna lays an egg, but Elsa is not yet ready to lay an egg. Her physiological system is not in the place where she can lay fertilized eggs yet. So what does she do? She takes the egg, chucks it out. Yes, she uh, takes her sister's egg and destroys it. Okay, that's awkward because Anna comes in the next day and sees that her egg is gone. Well, most birds lay one egg every day, so she lays another egg. Um, Elsa is still not ready to lay an egg. She takes the egg and chucks it out. And this goes on until Elsa is ready to lay eggs as well. Elsa will stop destroying Anna's eggs the day she lays her first egg. So that way, Anna and Elsa have eggs that are exactly the same age. The chicks come out on exactly the same day, and they both have a fighting chance to become adults. Now, let's consider a 3-bird scenario. So there are 3 sisters, Anna, Elsa, and their little sister. They're all joint nesters. Anna lays an egg. Elsa again checks it out. Little sister doesn't know that Anna laid an egg. So she lays an egg because she's ready now. So she and Anna are now coordinated, but Elsa is still not ready. And so all 3 females have to be, or all the joint nesting females in the group have to be ready and coordinated to start a nest. And we have seen that up to 40% of the eggs laid by any one female, so in joint nesting circumstances, up to 40% of the eggs are destroyed in this egg tossing game. Okay, so let's say they did that. They coordinated. They had they laid eggs. They hatched a few young. They fledged several young. But why do this in the first place? Why go through the whole rigmarole of nesting with your close kin when you can breed independently? The answer is that acorn woodpecker females only joint nest when there are very, very few or no independent breeding opportunities. So if you plot a graph of the number of females in the group and the population size, or which here is the same as population density, the number of groups that have multiple breeding females increases with population size. So as the population size increases, the number of those territories with the granaries remains the same, and the number of breeding vacancies that arise every year goes down. And so the next best thing to is breeding with your sister or breeding with your mother, which is better than not breeding at all. So because these females only live between 4 or 5 years, they only have 4 or 5 years, 4 or 5 nesting seasons to breed in. So if by year 3 they can't find a breeding opportunity, they will joint nest with their close kin. And they do pay a price for this. So this is data that comes from 867 nests of acorn woodpeckers that we have studied. And a single acorn woodpecker female, who is the sole breeder in the group, produces about 3.5 young per nest. Joint nesting birds only produce about 4.5 to 5. So they take a huge hit in the number of direct offspring they have. But they do get the inclusive fitness, which is the fitness that you gain from helping raise close kin in these nests. They do make the best of a bad job, though. So I hope you remember that I told you that for females, polyandry is the best case scenario. And in these joint nesting cases, yes, with an increase in number of females, there's also an increase in number of males. So they try to form these joint nesting coalitions only in groups where there are 2 or more males. And the males receive fitness benefits as well. So we talked about reproductive skew, right? How equitable the paternity is within breeding males in the same group. And so reproductive skew is low in groups that have multiple breeding females. So the males get an advantage as well. So if there are three or more males, all of them will get some direct paternity, as opposed to a group with only one breeder female, where 1 or 2 males get most of the paternity. So the take-home message is that sociality, your social system of acorn woodpeckers, changes with the environment and the population density. And they are really flexible. So they can go back and forth between a simple pair to living in these communal nests. So to sort of wrap things up, I just wanted to take us back to that simple observation that Frank Leach did in 1925, which was that more than 2 birds are feeding nestlings. And 50 years later, the acorn woodpeckers of Hastings, of Carmel Valley, California, are actually a textbook example, behavioral ecology textbook example of the role of helpers in reproduction that I didn't talk about today, but also about the evolution of cooperative polygamy, which is multiple males and females communally raising offspring. And with these radio tags that I just talked to you about, we are now getting into the sphere of animal social networks. So we are actually looking at data from these acorn woodpeckers to understand which 2 birds hang out more or which 2 birds hang out less, whether they maintain relationships outside their groups, how often they meet those friends or enemies, and if acorn woodpeckers have frenemies as well. So I hope I've convinced you that there are many flavors of sociality, that sociality has repeatedly evolved throughout the animal kingdom. And maybe human social systems are not unique, and perhaps not even the most complex social systems out there. With that, I will take any and all questions. Thank you for having me again.
Thank you. Woo. So lots of great questions. And let me get back to where I was in the list. There were 2 about the radio tags. Mm-hmm. One is, do those, Lisa Barbosa asked, do the radio tags interfere with flight or behavior?
Right. So thanks for bringing that up, Lisa. And no, they do not. There is a sort of an international, it's a convention, it's not a law, but the tag is always supposed to be less than 4% of the body weight of the animal. And this tag is less than 1% of the body weight of the animal. And these birds fly around, catch insects, raise chicks, and go inside and outside their nests. They do just fine. We have birds that have had a radio tag. The longest radio tag bird is now in its 5th year with a radio tag on. So they do just fine.
The tag doesn't fall off when they molt?
Yeah, so the tag eventually falls off when the little backpack we give it wears out. So we tie little bungee cords to it to keep it in place, but those bungee cords eventually wear off.
Sure. Chuck Tedeschi wanted to know what band the radio was transmitting on. Do you know?
434 gigahertz. So it's
Write that down. 434. Okay, you already did Matthew's question. Emma Shelton wants to know, will Sahas do another episode of Life of Birds?
is that a series that you guys have, or Emma, are you talking about?
I'm not actually sure. It's Life of Birds is in quotes. Is that it?
That's
Oh,
the
is that
BBC.
the?
That's the
Matthew asked a similar leading question about
Oh
it's
yeah.
way down
Well,
below, but are there other studies that you're working on so that we could pull you back for another speaker
yeah.
series
So
and
for,
talk on a different topic?
Sure.
I'll say, Sahas, and there are going to be more questions after this, of course, but this is fantastic. I absolutely adore it. And I know you said you studied them for 4 years, which leads me to believe that you've either been working on something else or you're continuing your study, but doing more advanced work on it. So my question to you is, when can we look forward to another talk?
Sure.
And
So
on what subject might it be?
yeah, so for my PhD, actually, I studied birds in the Himalayas. So I studied Himalayan birds and elevational distribution in Himalayan birds. And while I was doing my PhD, I got really interested in social behavior in birds, and that's how I did the acorn woodpecker project. I started working on the acorn woodpecker project, but at the Smithsonian, I'm actually back to working on Himalayan birds. So I can definitely talk about ecophysiology. So how Himalayan birds stay warm and how they live in rarefied atmospheres.
Well, we have a lot of elevations in the Sierra, so
Yeah,
some of that would apply.
Absolutely.
But while I have you, I have a question I'm just dying to ask. You must have seen at some point Lewis's woodpecker, another Melanurpes, at Hastings. And I'm wondering if you saw any overlap in behavior or diet or anything between the two species.
So there used to be Lewis's woodpecker is supposed to breed in colonies, but they're more sort of exploded colonies where they breed in the same area, but not like on the same tree, right?
Right.
There used to be a place on Hastings before my time there that had a Lewis's woodpecker colony, but they apparently have enough of a difference in their habitat. So acorn woodpeckers like this oak savanna with a lot of grass and big oak trees interspersed, and it looks like Lewis's woodpecker likes more forested habitats, and so I think they segregate by habitat. The only other woodpeckers that are at Hastings are Nuttall's woodpeckers are common, and red-breasted sapsuckers, but they're different enough that they don't really interact with each other.
Yeah, well, we see that same kind of segregation in San Antonio Valley. The Lewis's woodpeckers enjoy the wide open area with all the grass between the trees,
right?
And the huge oaks.
Mm-hmm.
Acorns are usually found more around the edges in the more densely forested areas. That makes total sense. Anyway, Barry has other questions from other folks, so I'm going to give you a chance.
Yeah, let me go on. So Isabel has a observation about woodpecker behavior, and with a question. She says, I once observed 2 woodpeckers store one acorn after another in their granary. The acorns were placed on top of a cut branch, which ended up resembling a cup. It seemed that many acorns had been deposited in this cup. Then I observed acorn woodpeckers going back and forth to get the acorns one by one and place them in a hole in the granary. Right. Did the woodpeckers gather the acorns there first with the purpose of storing them later all at once?
Well, I can't really get into the head of the acorn woodpeckers, and I don't know the intentions of the acorn woodpeckers, but we do know 2 things. One is that they will often fill even tree cavities with granaries. So we have this one group called Gator that regularly completely fills up 2 bluebird boxes that we have there with acorns. So they just keep dropping them in there until the whole thing is full of acorns. But also acorn woodpeckers, the coolest thing about acorn woodpeckers storing the acorns the way they do is that they never have to take them out, right? So they are jammed in there, and I'm sure you can try and even use tweezers to pull them out, but they're really difficult to pull out because they're really, really jammed in there. But acorn woodpeckers never really have to take out the whole acorn. They break the acorn in the hole using the hole as an anvil. And so they can just break the acorn up and take out little pieces, which are much more easy to bring out. And so that is, I have noticed, again, this is anecdotal, so I don't know how true this is, but most individuals have a sort of like favorite anvil that they use to generally break acorns that they might be able to take out, or even acorns when they're feeding on acorns that are fresh from the tree. So in the fall, you might see an acorn woodpecker. If you follow one individual back and forth, it might bring an acorn, sit at its favorite branch, and it may have like a little depression where it will break the acorn open. So
interesting. Well, while you're inside the acorn woodpecker's head, Matthew wants to know, how do they recognize each other? How do they recognize individuals?
So the research that has been done at Hastings tells us that they can recognize each other by sound. So and this was done in two ways. Acorn woodpeckers know each other's. They track group membership based on the sounds of birds. So let's say that you have individuals A, B, and C, and they all live in different groups. Now A knows that given where its territory is, B lives to its right and C lives to its left. Okay. Mm-hmm. And they know who the individuals are in that area. Now, if you play the call of woodpecker B with woodpecker C that lives together, it's going to go fly and check it out. So if you play calls of individuals that are not supposed to naturally associate with each other, they are really inquisitive. They want to go find out. The other thing they will do is if you play the call of a bird that has long been dead or has disappeared from the population, they will again go and check it out. So it was their neighbor, but hasn't been seen in the last 3 years. And if you play their call, they're like, wait, this guy was supposed to be dead.
That's amazing. That is amazing.
And so we know that they identify each other by sound, but also, as I'm sure you've understood, like if you can, especially the photographers, I want you to go back to your photos of acorn woodpeckers and look at them. And I'm sure you can tell acorn woodpeckers by their face as well. The third way I'm sure acorn woodpeckers can tell each other, and they actually use this, is if you've seen acorn woodpeckers or observed them, they have little white circles on their wings, and they're called moons or windows or whatever. And the shape of those circles is different for each bird. So often a bird will sit on the branch and put its wings out and do a spread wing display. And I think what they are doing is sort of self-identifying themselves every time they do that.
I'm here.
That's amazing. Well, I hate to sound specious, but the acorn woodpeckers all kind of sound the same to me. So
right, I know. Just like
you're just not listening carefully enough.
I guess not. That is truly amazing that they recognize each other by sound and by visuals. It kind of reminds me, how humans recognize each other by these subtle things that animals might not recognize. It's just fascinating to know that they recognize each other so easily, and it's so difficult for us.
Yeah, it's I don't know what to say. They're not as stupid as we think they are.
Well, I would never suggest that. It's just amazing to me that they're keying into things that we don't see.
Right. I mean,
right.
Yeah, and there might be other things that we don't know also. So, for example, I was just talking about this the other day, but or was it with you, Matthew? I don't know, but humpback whales don't identify each other by the unique pattern on their tail. They probably identify each other by some other
Right, of course.
other
we
metric,
use
right?
that because we can see that, but how likely is it that they can see that?
Exactly. So
Right.
Interesting.
Huh.
Are there any more questions, Barry?
All right. Yeah, there's a bunch. Let me try to get through them all.
bet.
Arvind wants to know, how does the news travel kilometers away in these woodpecker colonies?
that's a great question, Arvind. And thanks for asking that, because that's part of another part of the research, the radio tag work that I could talk to you about. Each woodpecker, on average, visits territories that are about 500 to 600 meters away. So each woodpecker in our population, irrespective of whether it's a male, female, or breeder or helper, visits 5 to 6 territories every day within a radius of 500 to 600 meters away. Now, that is an average, which means that some woodpeckers go much farther, and we have woodpeckers that regularly fly 2, 3, 4 kilometers away to other territories and then come back and roost with everyone else at night. So these birds are flying around all the time, and it seems like they either hear, because like I said, the power cycles are really loud, so they either hear the power cycles from far away, or they just watch other birds flying away to these power cycles. So they are definitely moving around a lot, more than we think they are.
Cool. Janet Teasel Cook says, I once had a banded acorn woodpecker who visited my upper deck and would vocalize until I'd come out and talk to him. Is this normal? It was great fun, ended for reasons they don't know.
Well, I don't think it was normal. Well, but at the same time, they are social animals. So if that animal was imprinted on you for some reason, it probably thought of you as a friend. And yeah, so I'm really glad that you enjoyed those conversations with the acorn woodpecker.
That is cool. I have seen birds socializing with humans in other situations too.
Right.
Akiko Oguchi says, I oftentimes see trees with granaries, but no woodpeckers nearby. Is this normal? Or could these be abandoned trees? Or maybe they've gone to go watch a fight somewhere?
All of those. So there are always some abandoned. So a good way to know is if there are any acorns in those granaries. So if there are acorns in the granaries, then there are definitely woodpeckers around. And one way of finding them is if you can reach any of the holes with acorns, try and just act like you're trying to take an acorn out. And
yeah, because they'll defend it.
The guards will come right away.
Well, that's a great thing to try.
Wow. I wonder if sudden oak death has had an impact on the population in California, because we lost a lot of trees, and of course they don't produce acorns any longer. Have you heard anything about that?
Well, it's sort of, I have heard of sudden. I mean, sudden oak death is more common in coast live oaks and less so in valley oaks. And so coast live oaks are actually not a preferred oak for making granaries for acorn woodpeckers, because the tree closes out the hole that the acorn woodpeckers make, because it's growing so fast. So acorn woodpeckers don't like to nest in coast live oaks or make big granaries in them. So they'll make granaries in dead parts of live oak. And so they haven't been affected as much as they would have been if they were coast live specialists. But at the same time, I'm sure, especially in the coastal areas, some of their habitat has gone down.
But you said that they like the diversity of oak species.
Right, exactly. So they generally have something else to fall back on.
Right. Okay. Good. Yeah.
Fantastic. Lynn asks, are the warriors the same or different across various days?
The warriors are the same. So the individuals from any one group are the same, because it's only those individuals that want to move to the group as a breeder. So it's the same birds from the same group coming and fighting. But again, this is anecdotal information. But there is strength in numbers. So the bigger coalition often tends to win. And we've had multiple instances of females coming to fight for their daughters. So a female will come to fight with two of her daughters and help them win a power struggle. The two daughters move into the new territory. Female mother goes back to her own territory. So there's sort of that nepotism that happens also, but it just tells you how important it is for an acorn woodpecker to disperse successfully.
Okay, there's more to the question. I'm trying to word it. She was wondering if some groups might try to be optimistic, coming in later when the warriors from earlier days might be exhausted or injured.
That's a great question, but it's really difficult to tag all birds all the time, and because these power cycles actually pull in birds from outside our study area, it's often impossible to have all the birds tagged or banded. So it's really difficult to know what the best strategy is.
Right. Okay, Isabel asks, Isabel says, I saw acorn woodpeckers building their granaries in palm trees. Is that common? I've seen them in palm trees too.
Yeah, I have seen, especially on Santa Cruz Island. I remember there's like a couple of, I mean, I'm sure on the mainland they do that as well. And so, yeah, it's any wood that they can easily bore into and make holes, they'll do it.
We have a palm tree outside our McClellan Ranch office full of holes.
Holes, yeah, there we go.
Yeah.
Why don't we take one more question, Barry?
Okay, and then I will take any of the questions that we didn't get to. I will take those offline and send them off to you, Sahas, and
great.
Maybe you can send us back a bunch of answers and we can distribute it to everybody. Okay, so Julie A asks, if all acorn woodpeckers live in family groups, what happens to the family of origin of the victors of a power struggle? Does that family now have a power vacuum that needs to be filled?
That's a good question.
Wow.
So
complex.
So let me get this right. Family groups. Yeah. So you have, let's say that you are a female, you live with a male and three helper females that are your daughters, and they can't breed in the same group as you because then they would have to mate with their dad. And so they go off and fight a power struggle and win that power struggle, and then they move, those three females move there. You can still make more helpers next year. So it's not a vacuum because the helper status itself is fluid, and helpers are always moving, dispersing away from their natal or birth territories. It's only a power vacuum when a breeder is missing. All the breeders of a particular sex are missing. I hope that answers your question, Julie.
Hopefully. So there are quite a few more questions. I'll gather them all up into one place and send them off to you. So I'm sorry we didn't get to all of them, but thank you so much for answering so many of these questions. Your talk is fascinating.
Thanks.
And people are really engaged. So go ahead.
Sahas, maybe you could hand back the controls to me.
Yeah, absolutely.
Cool, thanks. So I just have to tell you that this talk was incredibly interesting.
Thank you.
And this is exactly the kind of conversation I'd like to have on Speaker Series. You have a passion for this topic, incredible knowledge, field research. It was spectacular. And I just am looking so forward to having you back at some point with either a follow-up of this conversation or a new research project.
Sure.
But I know it's late in DC, so I want to let you get home. But I'm hoping when you get a chance, send me your mailing address. I'd like to send you something.
Great.
And I want to thank everybody for being here and remind everybody that we do Speaker Series almost monthly. And we're also starting to offer online classes about various topics. The current one is about gulls. So I'm looking forward to having folks join that. It's going well so far. But really, I wanted to thank Sahas for taking time out of his day after an exciting day in Washington, D.C. You gave us a spectacular summary of your detailed research. We learned so much about acorn woodpeckers, and we see them every day here, but I have the feeling we're going to look at them a little bit differently now. And that's thanks to you.
Thank you.
So,
I sure hope so.
thank you so much.
Cool.
I truly enjoyed it every moment. And I'm going to watch the video as soon as it comes out so I can catch what I missed the first time.
Great.
And,
thank you so much for having me again, Matthew. It
My
was great.
absolute
Great being
pleasure.
here.
So we'll
Thank
send
you so
some
much,
questions.
everyone, also for the wonderful questions.
We'll send you the rest of the questions, and we look forward to hearing more from you in the future.
Yep.
So thank you so much. So glad
Thanks
you could
again.
make it. And everybody have a wonderful evening. Enjoy your week, and join us next month for another talk. We're lining up a speaker right now, so I'll let you know when we get one.
All right.
Anyway,
Bye, guys.
good night, everybody. Thank you so much. God bless you all.
Good night.